Hello and welcome to Femap version 12. Going to show some of the new or the enhanced design optimization functionality, which is nastran solution 200 that we've added into Femap 12. So here's the cylindrical stiffened model we've used for some post-processing examples in the past. But what we've done here, I've kind of updated this model to change the way the properties are set up. So I have basically every panel with a separate plate property. So the model split up and divided in all these different plate properties. And what I'm going to do is I've already run natural frequencies at the current configuration. The lowest mode is about 83, 84 hertz. I'm going to thin down these plates and let nastran do it automatically for an optimized minimum weight, but keep the frequency above 50 hertz. So let's go ahead and set that up. So we'll go into model analysis. We've got our static run and our current normal modes run, but let's create a new. And this one needs to be design topology. Open that up. We'll start setting it up now. So definitely design optimization, minimize weight. We want to do normal modes. And the variables we're going to do is vary all those properties. So I want to create new property information here. So let's do multiple. And they've all been named plates. So I can use the text filter and look at just plates, pick them all. And then we'll do it by percentage. Let's go as low as 25% up to 100%. We'll say OK. So now we've got all our variables. The next thing we want to do is let's go in here and just check. We are running a modal run, so 0 to 10 hertz. We're only interested in the first mode, but we'll just calculate 10. And then let's go set up our limits here. So this is part of the new support. All types of new limits here, nodal displacements, forces, strain energies. But here we want to do in frequency. And I want it between a low of 50 and a high of 1,000. So basically keep it above 50. And we'll just say number 1 there. Okay. Now let's just double check here. Edit. Yeah, I want to make sure I pick. No, edit. It's the first frequency. We'll set to 0 there. All right, so at this point, I think we're ready to go. I'm going to go ahead and just say done here. Let's do a file rebuild because I deleted a bunch of results. Just clean that up. Let's save. And we're going to go ahead and run that analysis. So say analyze. Femap's created the nastran input file. Nastran's running. In the log file, you'll actually see design cycle 1 should jump in. We have 25 cycles set up, so it's going to run through 25. It's only 60 seconds it took nastran to run. So let's take a look at what happened. So if I go in here in a function, I'll just pick design variable 1, and we'll just show, and we'll see that basically started up here at this value, went all the way down to here. So the thing definitely got a lot thinner. Let's go ahead and shut that off. Let's do a little trick here. I'm going to do a file merge. And I'm going to bring across the mesh from the other model. Actually, I'll just bring everything over. So here's basically a copy of our model. And let's look at the thicknesses we have now. So let's do thicknesses as a criteria plot. And we'll also turn on the labels. So we'll kind of look at our thicknesses. Kind of this will be the before. I'm going to have to zoom in to see that. So there's that, and I'll actually turn on the thicknesses. So here's our before. Now we got a neat thing here from a design optimization run. And come in here and optimization, say update from the punch file. And what this is going to do is, to go to where the file's at. All right, so it's 200. Just check the date. That's the one I just ran. Let's bring him in. And those will now update all those properties, and we can see how much thinner the model got. So you can see that all these panels were thinned way down. And just for fun, let's go ahead and rerun this. We'll say analyze. We'll run the modes. This will be the new thinned down structure. It's running, already done. Look at the results. You can see the mode 1 is down at 49.85 hertz, so it took it right down there to 50. I'm going to turn off those labels, thin the structure up, and now obviously you'd want to do a stress run, but the nastran optimization is taking care of what it needed to do here.